Mentioned the hamburger ellipse, and there's also a hot dog ellipse. Whenever a is greater than b, so if the denominator of the x squared term is larger than the denominator of the y squared term, we're going to get a hamburger ellipse. We're going to get an ellipse that is wider than it is tall. If a is less than b, we get the hot dog ellipse, which means it is taller than it is wide. Now, great question. What happens if a is equal to b? That's right, you guessed it, that actually would give us a circle. So, to recap, if a is greater than b, we get a hamburger ellipse. If a is less than b, we get the hot dog ellipse. And in the event that those are actually equal to each other, we get a circle. Now, the last thing that we're going to do is we need to talk about how do you actually find the foci of the ellipse. In some of the problems we've done, I've given you the foci. In this case, I haven't given you the foci, but I want you to find them, and we're going to go through the process to do that. All right, Mavericks, let's keep going. So we've got a lot going on in this graph. Let's go back to the definition of an ellipse. The definition of an ellipse is it's the set of all points in the plane that are a combined constant difference from 2 points known as the foci. So here we go. The way I've got this set up, h comma k represents my center. If I go a spaces to the right and I go a spaces to the left, that's going to get me my horizontal axis of symmetry. If I go b spaces up and b spaces down, that's going to give me my vertical axis of symmetry. And this north point right here is a point on the ellipse. So if I take the combined distance from focus point number 1 to the north point, plus the distance from the north point to focus point number 2, that has to be, like imagine that's the string that we were drawing on the board. That is going to be the combined total distance. But the string, what we also saw when we did this, had to go a spaces to the left and a spaces to the right. So what that means is, and this is actually going to happen for every single ellipse, whether it's a hamburger or a hot dog, if I can find the length of the major axis, that's going to be the longest one, that is actually always going to equal the combined total distance from the foci to a point, from the point to the other foci. So what does that mean? It means that the string that we're looking at would actually be 2a spaces long. Since this is the north point, it makes an isosceles triangle, which means the hypotenuse for this right triangle is going to be a, the hypotenuse for this right triangle is going to be a. This is one of the foci that we're looking for. We've got a right triangle in here. What I don't know is the distance from the center to the foci. So what I do know is from the foci to the north point, I went up b spaces. I know that the hypotenuse over here is a, and I don't know this side. Well, fortunately, we've got our friend the Pythagorean theorem, and I know this is not written in the way that you're used to. We're used to a squared plus b squared equals c squared. But this length over here, the piece that we're finding, which I just have indicated as a question mark, we're going to call c. So c squared plus b, in this case, is how far up you went. C squared plus b squared equals the length of the hypotenuse squared, which for us is a. If I solve this equation for c, we can move the b squared to the other side through subtraction. We can take the square root. So c is going to be the square root of a squared minus b squared. That's how it's going to work for all of our ellipses. If you want to find where the foci are located, you find the center, and you're going to move the square root of a squared minus b squared spaces to the right. You're going to move the square root of a squared minus b squared spaces to the left, and those are going to be your foci. So with that, let's take it back to the example we were doing before, and we can close out on this part of the conversation. All right, folks, we're in the home stretch here. We've already graphed x minus 4 squared over 36 plus y squared over 9 equals 1. We found the center. We found the north, south, east, and west points. What we need to do is find the foci. What we learned just a moment ago is that the foci, the distance from the center to a foci, can be found by doing the square root of a squared minus b squared. For this specific example, we know that a is equal to 6 and b is equal to 3. So we just go right ahead and we plug that in. If c is the square root of a squared minus b squared, then in this case c will be the square root of 6 squared minus 3 squared, which is the square root of 27. That square root of 27 represents how far from the center the foci are located. So if this is 4, 0, and the vertical axis, the major axis of symmetry is horizontal, I'm going to go square root of 27 spaces to the right to get to a focus. That'll give me 4 plus the square root of 27, 0. I'm going to go the square root of 27 spaces to the left, which means the foci will be at 4 minus the square root of 27, 0. What we're going to do over the course of this week is we will continue to play around with the ellipse. We're going to look at some more hamburger ellipses. We'll look at the hot dog ellipses, which are going to be tall and skinny, like I would hope to be. What we're going to find with the hot dog ellipses, the foci will always be located on that, in that case, on the vertical axis of symmetry. We'll, of course, continue to play around with slope of the tangent line. We would expect here at the north point, 4, 3, tangent line will be horizontal. It'll also be horizontal here at the south point, 4, -3. Tangent line will be vertical at 10, 0, and over here at -2, 0. For this particular problem, we have 2 y-intercepts. We didn't actually bother to find those in this case, but we can see from the graph that there are 2. And we can also see that we have 2 x-intercepts in this case because the horizontal axis of symmetry is the x-axis. We actually already found the x-intercepts, and so with no extra work, we know that the x-intercepts are at 10, 0 and -2, 0. I hope this helps. I especially hope it helps you go from good to great. See you in the morning.